It's Sum time!
Why are white blood cells important for us?
'Cause they give burgers for free.
Nah. Besides red blood cells, platelets, and plasma, our blood also contains white blood cells. White blood cells, or leukocytes, are important for us as they are a very essential part of our immune system. They protect us from diseases and infections. Let's look at the 5 major types of white blood cells. They are neutrophils, basophils, eosinophils, lymphocytes, and monocytes.
Wow!
Neutrophils ingest or engulf harmful invaders and kill them. This process is called phagocytosis. Basophils release a chemical called histamine, which dilates blood vessels, increasing blood flow, and thus helping transport more white blood cells to the infected site. Eosinophils are involved in combating parasites. Lymphocytes create antibodies to fight the invaders. Last but not least, monocytes clean up dead or damaged cells and dead microorganisms. Hence, they are also known as garbage trucks of our immune system. Why do blood types matter?
'Cause burger types matter.
Nah. Usually, our blood is classified into 8 types, namely A positive, A negative, B positive, B negative, AB positive, AB negative, O positive, and O negative. This classification is based on the presence, absence, or combination of specific antigens in our red blood cells. If we have A antigen, then our blood type is A. If we have a B antigen, then our blood type is B. If we have both antigens, then our blood type is AB. And lastly, if we neither have A nor B, then our blood type is O. The positive and negative factor is determined by the Rhd antigen. If we have Rhd antigen, then we are Rh positive. Otherwise, we are Rh negative. But what is the use of these blood types? Our immune system produces antibodies against the antigens we don't have. So, during transfusion, if wrong blood is injected, our antibodies will recognize the unknown antigen as an invader and start attacking it. This can cause transfused blood to clot, which can be potentially fatal. What is blood pressure?
It's a form of acupressure.
Nah. In order to deliver oxygen and nutrients to each and every cell of our body, our heart pushes blood through tubes called blood vessels. As the blood moves, it exerts force on the vessel's walls. The measurement of this force of blood on the walls is called blood pressure. The ideal blood pressure reading is about 120 over 80 millimeters of mercury or slightly below it. But why does the reading have 2 numbers? It is because our heart is constantly contracting and relaxing. During a phase called systole, our heart contracts to push the blood through arteries, thus increasing the pressure. So, the bigger number indicates the systolic blood pressure, whereas during diastole, our heart relaxes, decreasing the pressure. So, the smaller number indicates the diastolic blood pressure.
Blood rain! Ah! Relax! Blood rain has red-colored water droplets. There are various reasons behind this. Around Sahara Desert, brownish dust and sand carried by storms mix with water droplets and clouds, giving rain its brownish-red color. In Kerala, red spores of algae called Trentifolia annulata got carried by wind and mixed with water droplets, causing blood rain. While in Zamora, Hematococcus pluvialis algae got caught in rain clouds, got stressed, and produced a red pigment called astaxanthin, causing blood rain.
Why is blood red in color?
'Cause every day it bathes using red paint.
No. Our blood mainly consists of a liquid called plasma, red blood cells, white blood cells, and platelets. However, the color of our blood is basically because of red blood cells. Each of the red blood cells contains hemoglobin. Hemoglobin is an iron-rich protein. When hemoglobin binds with oxygen, the interaction between them gives our blood its red color. Moreover, like human beings, not all animals have red-colored blood. This is because the blood of some animals, such as octopuses, spiders, etc., has hemocyanin instead of hemoglobin. Hemocyanin is a copper-containing protein. When hemocyanin binds with oxygen, their interaction gives the blood a blue color. The blood of some lizards has biliverdin instead of hemoglobin, which give their blood a green color.